Hello and welcome to 6.2.1, What If I Multiply? Now, in the previous lessons, we've been doing rigid transformations. When you do a slide, same shape, same size, same direction. When we did a turn, it was same shape, same size, different direction. When we did a flip, same shape, same size, opposite direction. Today, we are going to be multiplying and we're going to see what happens with those shapes. So our first problem here is problem 6-42. You have a graph, 6-42, 6-42. You have a graph, and what I want you to start by doing is go ahead and plot those coordinates. Pause the video, plot those coordinates. Okay, welcome back. Now, you have plotted those 4 points. And here is the question for today. What's going to happen when you multiply the coordinates? In this problem, we're going to multiply by 2. Off to the right-hand side, you have a blank area. In that blank area, I want you to please write like this, B, I predict. Pause the video, make a prediction, what's going to happen. Okay, welcome back. You've made your prediction. There's any number of predictions that students have made regarding what happens when I multiply those coordinates by the number 2. So what we're going to do, this is underneath your prediction, you are going to have these 4 coordinates. And with these 4 coordinates, you are going to write times 2 underneath it. Okay? You can write the times 2 on the left. You could write the times 2 on the right. You could write a times 2 underneath every single one. Doesn't matter. And you're thinking about this like multi-digit multiplication. But you're not following ones place, tens place rules. You're following an ordered pair. So, for example, 2, 1 times 2 is going to be 4, 2. Notice the 2 got doubled and the 1 got doubled. Over here, if you were doing this problem, I would say 2 times 5 is 10, and 2 times 2 is 4. Okay? Now what I want you to do is pause the video, finish multiplication, and plot those points. Okie dokie. You have done all the multiplication, you have plotted your points, and you should end up with a shape that is right about here, and it looks about that big. That's what you should end up with. Now let's make a comment about your prediction. Did you predict that it would change size? It did. Did you predict that it would change location? It did. How much bigger did it get? Some people said it doubled in size. No, it did not double in size. It actually quadrupled in size. However, but the side lengths did double. The side lengths doubled from 4 to 8, from 3 to 6. You can see how some of these side lengths did double. You probably also noticed that it doubled the distance away from the origin. It was up 1 over 2, and now it's up 1 over 2 twice. Okay? It's double the distance away. Okay? Those are the key relationships I want you to notice as we did this dilation of times 2. What I would like you to do now is please go ahead and copy these notes. A dilation is when we multiply the coordinates by a number. The result is a larger side length and increased distance from the origin. Now, that's assuming that the number is greater than 1. Pause the video to finish recording this sentence off to the right-hand side of the graph. Pause the video now. Okay, let's go ahead and jump into problem 6-43. The students in Miss Stanley's class were studying what happens to the graph of a shape when both of the coordinates are multiplied by the same number. They have these 4 questions. So in your notebook, you are going to notice that you have this triangle. Okay? What's going to happen to this triangle if these things happen? We know what happens with a double. A double, the side lengths doubled. Okay? So let's go ahead and dive into this graph. Let's talk about when we multiply by a half. Well, if the side length doubled when we multiplied by 2, what's going to happen to the side length if we multiply by half? Can't we reason that the side lengths now, off to the right-hand side, you see these questions, you should write the response. If we multiply these coordinates by a half, instead of negative 6, 8, I have negative 3, 4. Instead of 6, 4, I have 3, 2. And instead of 2, 4, I have 1, 2. And I want you to notice my side lengths have been cut in half. Notice the original was 8 and the new is 4. The side lengths are half. Okay? And you can see that this triangle has been shrunk. It's almost like you're zooming out. I also want you to notice that the angles are the same. It still looks like the same shape. It's a similar shape, but it's a different size. When the multiplier was 2, it got twice as big. The side lengths got twice as big. When we have a number less than 1, half, the side lengths are half the size. So question, what will happen when we multiply by 1? What happens anytime you multiply by 1? It's going to stay the same. It's going to stay the same. I don't need to do any of this multiplication. It is going to stay exactly the same. Same place, same size, same shape. What happens if we multiply it by a negative 1? Do you remember last week when we multiplied by a negative 1? We were focusing on flip, and we would multiply this negative 6, and it would become a positive 6. And then we would take that positive 8, and we flip it down here to be a negative 8. So if we multiply by a negative 1, I want you to notice what happens to my shape. So here's one coordinate. Here's my, original right here. And 6, 4 right here. What happened to my triangle? Same shape, or same size, I should say. But what happened to its location? Now, I'm hoping that you can recognize this is a rotation of 180 degrees. Now, if you have not plotted those points, copied that down for the orange triangle or the green triangle, I do want you to have those two triangles down. So if you have not done that, pause the video so that you can copy down those two triangles' locations. Okay, the last one. When we multiply by a negative 2. Well, what happens when you multiply by a negative? What happens when you multiply by 2? Doubled side length. So if I combine those two things, when we multiply by negative 2, I'm going to rotate 180 degrees because of the negative, and I'm going to double side lengths because of the 2. So let's make sure we have both of those things. When we multiply by negative 2, we're going to rotate 180 degrees and double the side lengths. Now, today's lesson is all about investigating what happens to a shape when we are doing a dilation. See, you can take any shape. Here, let me go ahead and give you, let's do a simple square rectangle, okay? If I have this shape, and if I take this shape, tools, screenshot, needs to be an image. If I take this image, okay, notice what happens to the shape. Notice the shape is very similar to the shape. I am dilating it bigger and smaller. I am zooming the shape in and out. The shape still looks like the rectangle. The image still looks like the image. It's just getting smaller or bigger. And that's the key essence of today. That when I multiply the coordinates, I'm making the shape bigger, I'm making the shape smaller. If I multiply by a negative, I'm doing a rotation on the coordinate grid. Okay, it's kind of like saying, oh yeah, I'm going to make it the opposite. I'm flipping it. Okay, so you'll notice a couple lines in the very bottom for problem 6-45. I want you to title this dilations. Okay, and what you are going to do is 4 things. Doesn't have to be 4 sentences. I had people do this today in 2 sentences. But what you are going to do is 4 things. Explain how multiplying the coordinates of a shape affects the shape. How does the size change? This is talking about the shape. Does it still look like the shape? And this is talking about the size of the shape. Sometimes it's bigger, sometimes it's smaller. Maybe it doesn't change at all. What happens to the angles? Does it change? Does it not change? How do these results depend on the multiplier? 2, 1, half, negative. How does that matter? Be specific. Use examples. Okay, you've got multiple lines. Write a couple sentences addressing the questions in this paragraph for 6-45. Thanks for coming today. I hope this is helpful. I hope to stay up with you guys. Make sure that you are getting all the lessons that you need. We will be here again tomorrow. We'll see you then.